the population paradox. Let's talk about apportionment. With the population paradox, it says that when populations change for a number of states, if one is going to lose a seat, it should be the one with the slower population growth. If the opposite happens, it's an example of the population paradox. So let's use Hamilton's method to determine the appropriate apportionment for desired 75 representatives. We have 3 states, West Elm, East Hickory, and North Woodside. To find the appropriateness here, we start by finding a standard divisor. With that, we need the total population. So 240,000 plus 190,000 plus 215,000 gives me a total population of 645,000. I divide that by my 75 representatives, and my standard divisor comes out nicely at 8,600. I then can find my standard quota for each state. So for West Elm, I take my population of 240,000 divided by 8,600 for a standard quota of 27.907. These are rounded to 3 decimal places. East Hickory, 190,000 divided by 8,600 gives me a standard quota of 22.093. And North Woodside, 215,000 divided by 8,600 gives me a nice, not round number of 25 for the standard quota. So standard quotas, we need the lower quota for Hamilton method. So 27, 22, and 25. When I add those together, they sum to 74. Well, that I need 75. So one more representatives need to be assigned, and it's going to go to West Elm, because if you look at the decimal approximations, we have 0.907, 0.093, and North Woodside doesn't have a decimal. So it goes to the one with the largest, which is 0.907, West Elm. So my new final quotas are 28, 22, and 25. Great. But now the population increases. So does the population paradox occur here? So West Elm population is now 280,000, an increase of 40,000. East Hickory is now 200,000, an increase of 10,000. And North Woodside increases to 220,000, an increase of 5,000. So thinking through this, if someone is going to lose a seat, it should be that the state with the slowest increase, right? It looks like it would be North Woodside because that's the smallest one. But we'll get to that again in a minute. So we got to do the process again. So we start by finding the standard divisor. We add our new populations together. 280 plus 200 plus 220 gives us 700,000. We divide our new population of 700,000 divided by the 75 seats we have. This gives us a standard divisor of 9,333.333. And again, we find the standard quota. So our new populations divided by our new standard divisor. So for West Elm, we get 30.000. East Hickory is 21.429. And North Woodside gives us a new standard quota of 23.714. Lower quotas, 30, 21, and 23. When I add those together, I again get 74. So when I look at the decimal approximations, now North Woodside has the largest decimal, 0.714. So they receive the extra vote or the extra seat. So West Elm has 30, East Hickory has 21, and North Woodside has 24. But how do I know? How do I know what that means? Now let's look at the number of representatives and compare. So the original quota is in our first column here of 27, 22, and 25. And then we show the population increase. So we have the relative change there, the change in population, and then the percent increase. So West Elm had a 16.67% increase in population. North Woodside had the smallest growth, and East Hickory was in the middle. But you can see East Hickory and North Woodside were both pretty small in terms of growth. So the 2 states that lost representation, right? East Hickory had 22 and now they have 21. North Woodside had 25, now they have 24, whereas West Elm now has 30. So they gained 3 seats and each of the other states lost a seat. But the 2 states that lost a seat had the slowest growth, which should happen. So because the state that had the largest increase, both in absolute and relative change, saw an increase in representatives, while the 2 slower growing states both lost seats. Therefore, the population paradox has not occurred because happened the way it should have. If someone's going to lose a seat, it should be those with the lower or slower growth population, while the larger growth should be the one that earns or gains a seat, or 3 in this case.